All right, so today we're going to be talking about standard deviation and data distribution. So standard deviation is a stat that we can find that helps us figure out the spread of our data, basically. So that can be important in a variety of situations, like for a teacher, for example, doing test scores like this example that I'm looking at right now. It can kind of tell, like, are the students, so say they have like a 70% average. Are the students all getting around 70% to get that average, or are some students getting like 100% and some getting like 0%? So ideally, you'd probably want the majority of the class to get close to 70% or higher if possible, right? We don't want any students failing. But that's basically what standard deviation can help us find. It's often used in like manufacturing, for example, where you don't want to see, you want to consistently see very little defect in your products, right? So standard deviation is something they track and use quite often in manufacturing. So things like that. So the way to find standard deviation, and again, I already said in the previous video that you can do it on the calculator, but the way to find it by hand is a little bit more complex, and I'll kind of talk you through that right now, just to get you a little bit more appreciative of the calculator. So to find standard deviation, you first have to find the mean and the number of total numbers. Again, you need that to find the mean anyway. But to find the mean, you add all the numbers together and divide by the total number of numbers, right? That gives you your mean. Now this is a chart that kind of walks you through how to do the standard deviation by hand. So you go through and you write down your test scores, and then write down or subtract the mean from each of those test scores. Then you take that number and square it, and then you add all those together, and then you end up dividing by the total numbers and then square rooting. So a little bit more complicated. So a lot of different things you have to do, things to it like 4 different times to actually find the standard deviation. Now the calculator will do it just by entering in the data set. So again, to enter in the data set, you go to data, and I already have the data entered, but I'll clear it and enter it again. So to enter it again, you just write it in 22, enter, and you just do that for each number: 99, 102, 33, 57, 75, 100, 81, 62, 29. Okay, so 10 numbers entered, that's what I want. And then to do the stats, I need the second option of the data menu. So second, and then data again. And again, I go to one variable, stats, and then I go down to calc. And again, this is the same menu we did for the box and whisker and for mean, median, and mode, all that kind of stuff. So standard deviation looks like this symbol right here, the little O with the line X. So we scroll down until we see the standard deviation symbol, and that tells me my standard deviation. Standard deviation is 28.87. Okay, so not too bad, but again, the bigger this number is, the more spread out the data is. The smaller that number is, the closer together all my data is. Okay? If all these numbers were within like 1 or 2 apart, this would be like very small. Okay, so if we're looking at standard deviation, the bigger the number the standard deviation is, the more spread out your data is. The smaller it is, the more closer it is together. Okay? And that's basically all you're doing for standard deviation. Again, you just enter in the data set on your calculator, and then it will spit out your answer for you. Okay? You don't have to do it by hand. You don't have to find the mean and then subtract the mean and then square it and square root and blah, blah, blah. Okay? Then for data distribution, this is when we are looking at different data sets, and there are several different types of data that we're going to talk about. Okay, and they're listed kind of right here. So they're symmetrical, which basically means we have like a normal distribution. There's, well, another way to say that is just normal. Yeah. Let's look at this. This is better. So we have our normal distribution, or symmetrical, which again basically just means that the median and mean are right next to each other, and they kind of split the data in half. Okay. Then we have our skewed data, which students often get confused on which way it is. Because if we look at it, all the data seems to be skewed to the left on this, right? But when we talk about what's being skewed, we're talking about the relation of the median to the mean. Okay? And if we look here, even though all the data is kind of on the left side, the mean is to the right of the median, which skews it right. Because that's what we kind of talk about when we talk about skewed. Easiest thing to do when you're identifying these is you just look at the tail. Okay? If the tail's on the right side, it's going to be skewed right. If the tail's on the left side, it's going to be skewed left. Okay? And again, if it was a bar graph, it would look like that, or histogram. Okay? Then we also have our uniform, which everything is the same. Median is the exact same as the median. Okay? And then we have our neither, which is when we have holes or it's kind of all over the place kind of graph. Okay? So let's look at some examples and we'll see if we can figure out what's what. So if we look at A here, this one would probably most likely be described as skewing right. Okay? Now I would probably also accept a neither because it has that hole there. Okay, but because if we look at the data as a whole, it's obviously got this tail of data over here to the right. So I would say this is skewing right. Skew, my pen's going out. Skew right. Or neither. I would take either answer on that one. This one, I know it's not exactly symmetrical, but this is a normal distribution, or symmetrical, however you want to write it. This one is also, again, we look at the tail, this one is skewing right. This one, if we look at the tail, it's on the left, so skew left. This one, they're all the same, so that one's uniform. And again, tail, so skew right. And that's basically all you're doing when you're looking at data distributions. You're just basically looking at the relationship of the mean and the median. And normally they're pretty close to each other, so that would be a normal distribution. If you've got your data clumped so there's a tail on the right, that's skewing right. If you got a tail on the left, it's skewed left. And if they're all the same, that is uniform. And that's all there really is to data distribution. So there's that.